Okay, so here we have a problem, and let's read this. The length of the stretch in millimeters of a spring, okay, we're stretching a spring, is proportional to the weight in grams attached to the end of the spring as shown in the graph. Okay, so they graph it for you, and here is the relationship. The first thing we need to find out is find and interpret the constant of proportionality. Okay, so to find the constant of proportionality, which is also the unit rate, okay, is very straightforward. All we need to do is to find the slope. And to do that, we just take one of the points and calculate its constant. Okay, so let's say, for example, we decide to take 5 over 25. I'm sorry, 5 comma 25. Okay, so this second point up here. So the ratio is going to be y over x, which is the length of stretch divided by the weight. Okay, weights in grams, stretches in millimeters. And if we plug in the numbers, we get 25. Okay, this is the y value of that coordinate, divided by 5. And if we divide 5 into 25, we get a constant of 5. Okay, so finding the constant is fairly straightforward, or at least hopefully it is fairly straightforward now. Now you have to interpret what this means. Okay, what this means is that for every stretch of 5 millimeters, it is due to 1 gram of weight attached. Okay, let me say that again. For every 5 millimeter of stretch, that is equivalent to 1 gram of weight. So in other words, the constant of proportionality or unit rate, okay, this is our slope of 5, is 5 millimeters of stretch per 1 gram of weight attached. Okay, what this means is, if you understand the proportionality or the constant of proportionality, then we know that for every gram it goes up by the same factor. In other words, if we have 2 grams of weight, it's going to stretch 10 millimeters. Okay, if you take a look at the graph, 2 grams, it'll take us to 10. 3 grams takes us to 15. 5 grams of weight, it's going to take us to 25. So part B of this problem asks us to explain what the point 0, 0, 1, 5, and 5, 25 represent. Okay, and I've kind of answered that question already, but here is what each of them represent. So the point 0, 0 represents the length of the stretch of the spring when no weight is attached. When no weight is attached, there is no stretch. At 1, 5, this point represents the length of the stretch of the spring, 5 millimeters, so it'll stretch 5 millimeters when 1 gram weight is attached. And finally, 5, 25, that point represents the length of the stretch of the spring when 5 gram weight is attached. So when 5 gram of weight is attached, it stretches 25 millimeters. So to summarize, as you can see in this graph, this is a straight line, and it's representing 2 relationships that are proportional, because it is a straight line and it goes through the origin. Okay, I hope this all made sense to you. If you have any questions or any of this is not clear, please go back in the recording and review what I've covered. Thank you.